Welcome, class. So, last time we looked at percent composition, right? And this allows us to break down the formula, the compound, right, into how much of that compound is coming from each particular element within the compound, or how much of the mass is represented by the mass, or by the mass coming from each particular element. Now, what if we want to, instead of breaking down the formula, right, into the composition, right, what if we know the composition and we want to try to figure out what the formula is? So that's what we're going to look at today. Now, directly, we can find what we call the empirical formula. So early on, we looked at the difference between molecular formula and empirical formula. Right? So back in chapter 5, we had these two different ways that we could express the formula. So remember, the empirical formula, right, is the simplest whole number ratio of the atoms or moles of elements in a compound, right? Now, remember, formulas are not based on mass, right? That's something we have to really make sure that we understand, that it's based on either the individual atoms, if we're talking about a single molecule or formula unit, or it's based on the moles of the individual atoms of the elements, if we're talking about, a large number, right, or a mole of that molecule or formula unit. So the empirical formula is what we can determine directly, right? Directly, if we know the percent composition information, we can directly come up with this empirical formula, right? The simplest whole number ratio. Now, that may or may not be the actual molecular formula for the compound that we're working with. So we have a couple steps that we're going to follow. So we're going to assume that we're starting with the percent composition here. Now, the first thing you're going to do is you're going to use the percent composition, or take that percent composition and convert it into grams. Now, how do we do that? Well, the basic idea is we're going to have to take whatever that percent composition times by the sample size that we have. Now, most of these problems are not going to give you a particular sample size, so you can pick whatever sample size you want to. Now, the easiest thing to do is to use 100 gram sample size, because that means your percentages directly convert into grams. So if something is 50% of some element, if we have 100 grams, that means it's 50 grams. So if we choose 100 grams as the mass of our compound, then we don't have to worry about doing the actual multiplication. Those percentages just automatically become grams. Now, with that being said, you could start with any amount here in terms of mass compounds and just multiply your percentages by that amount, and that would give you the breakdown. Now, if for some reason you're given the information already in grams instead of percentages, well, then of course you don't need to do that. So once we have our grams of each element at this point, we're going to convert those grams into moles of the element using the molar mass, right? So we're going to convert all of our moles of our elements into grams, all of our grams of elements into moles of the element, right? Because remember, that's what our formula is going to be based on, is moles of each element. Now, at that point, we know the ratio, if you will, right? We know what the ratio of the elements in our compound is. And we could write out what you might call a pseudo formula using this number of moles, our subscript. Now, this is probably not going to be the actual empirical formula, because remember, these have to be whole number ratios. And so the next couple steps are things that we can do to convert these sort of raw numbers, right, into whole numbers. So the first thing that we always do is we're going to divide through by the smallest number of moles. Right? So this is going to take that smallest number and make it 1, and then everything else will be relative to that. Now, this may well give you whole numbers, right? Now, so we have to be a little bit careful here right, when working with this book information, right, these problems in the book. If your answer is within, say, 0.1 of a whole number, then we can go ahead and round, right? If your answer is not within 0.1, right, then we need to find some small whole number that we can multiply by to turn all of our number of moles into whole numbers. And you can see sort of a guide here. So some of the common ones are, right, if your number of moles ends in a 0.25 or a 0.75, we're going to multiply it by 4, right? If it ends in 0.5, we can multiply by 2. If it ends in like 0.33, 0.66, somewhere near there, we can multiply by 3 to turn those numbers into whole numbers, right? So we can sort of use that, if necessary, as part of our process. Okay, so now we have sort of a procedure that we can go from percent composition to empirical formula. Now let's work through an example. So we have this compound vanillin, right? This is the compound responsible for the vanilla flavor, right? And we know it has a mass percent composition of 63.15% carbon, 5.3% hydrogen, 31.55% oxygen. Notice these percentages should add up to something very, very close to 100, right? Because it's representing all of the mass of the compound. Now I want to determine the chemical formula. So I'm going to go through my first step, and I'm going to convert these into grams. And so I'm going to arbitrarily pick a 100-gram sample. So that means 63.15% of that is 63.15 grams of carbon, 5.3 grams of hydrogen, and 31.55 grams of oxygen, right? That's where my 100 grams comes from. So now I'm going to take each of these, and I'm going to convert these grams into moles of each element. So I'm going to take my 63.15 grams of carbon. I'm going to multiply it by 1 mole of carbon, 12.01 grams of carbon. We do the same thing for the hydrogen, 5.30 grams of hydrogen times 1 mole of hydrogen equals 1.1 grams of hydrogen. And lastly, 31.55 grams of oxygen. Each mole of oxygen, 16.00 grams of oxygen. So if I do my math, right, my grams of carbon cancel here. So if I do this, I get 5.258 moles of carbon. I do the same thing here. I get 5.248 moles of hydrogen. And here, 1.972 moles of oxygen. Now notice at this point, I'm not worried too much about significant figures. I'm going to keep extra significant figures here because I don't want to introduce any rounding issues. Okay, so if we look at our steps here, now we have moles of each. So we've established what our basic ratio is. Right? So I could write a formula here at this point, right, where I have carbon, 5.26, hydrogen, 5.25, oxygen 1.97. But of course these are not whole numbers, right? So I need to turn these into whole numbers somehow. So remember, our first thing is to divide by the smallest number of moles. So in this case, that's the 1.97. So I'm going to take all of these and divide through by 1.972. And if I do that for the carbon, I end up with 2.67 moles of carbon. The hydrogen, 2.66 moles of hydrogen, and one mole of oxygen. So now I'm getting closer, right? Now my formula, right, has gone from here to C2.67 H2.66O1. Right? But still, not everything's a whole number. I got one whole number, these two. So if I look back at my things, remember, if I have fractions that end in 0.6667, then I can turn them into a whole number by multiplying by 3. Now the important part here is I have to multiply everything by the same, so it has to be able to turn everything into a whole number. And so if that's not showing up here, not working, then perhaps you made a mistake earlier on, because you should be able to have one whole number that will turn everything into a whole number if they're not already. So in this case, it's going to be 3. So I'm going to multiply each of these by 3. And 2.67 gives me 8 moles of carbon, 8 moles of hydrogen, and 3 moles of oxygen. So now I have whole numbers. Now I can write this as an actual formula of C8H8O3. And that's going to be my empirical formula for vanillin. Now, all I know right now is that is my empirical formula. I have no way to know if that is the actual molecular formula unless I know what the molar mass of the actual compound is. So, with that being said, how do I go from converting an empirical formula into a molecular formula if I want to do that? Well, like I said, the only way we can do that is if we're given the molar mass. So if we are not given the molar mass, then the far as we can get is the empirical formula. But if we are given the molar mass along with knowing our empirical formula, then we can come up with the actual molecular formula, because the molecular formula will always be some multiplier of the empirical formula. Either it'll be the same, or all of the subscripts will be 2 times, 3 times, 4 times, etc. Because remember, the empirical formula is just a simplified version of the molecular formula, right? It's just the simplest ratio of the elements as opposed to the actual ratio of the elements. So the key here is finding what N is. And this is why you need to know the molar mass, right? So let's take an example. Let's say that I did a problem and I figured out that my empirical formula was CH. And I was told now that my molar mass of this compound equals 52.08 grams per mole. Okay. So to figure out what the multiplier is, I need the molar mass divided by the empirical formula molar mass. So the molar mass here is the 52.08. The empirical formula molar mass is adding up the elements in the empirical formula. So I have carbon, so 12.01 grams per mole, plus 1 hydrogen, 1.01 grams per mole. So the empirical formula mass, right, is 13.02 grams per mole. So if I want to calculate N, it's going to equal the 52.08 grams per mole divided by the 13.02 grams per mole. And if you do that, you get an N of 4. So that means my molecular formula is equal to the empirical formula CH times 4, or C4H4. Right? So I'm going to take my subscripts of 1 here and multiply them by my multiplier. And so the actual molecular formula would be C4H4. But the only way we could do that was to know what the molar mass of this actual compound. Otherwise, we don't have any idea knowing if it's CH, C2H2, C3H3, C5H5, etc. Right? So that brings chapter 6 to a close, right? And so we've learned much more about how to work with, how to quantify the amounts of materials that we have, whether we're dealing with elements or compounds. And we've learned how to work with those chemical formulas and what those chemical formulas mean in terms of the how many atoms in the formula and how we can work with that to do our percent composition, our mass percent composition, and then using a mass percent composition to get to an empirical formula. So next time we will be looking at chapter 7.